Hello everyone. Hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT IC department. Welcome to the video tutorial series of the data communication and the computer networks. When the user makes a call with the help of the telecommunication devices and using the service of the telecommunication companies, which kind of things they are using? That telecommunication companies are allocating the fixed channel to that user for the temporary use, right? So how that channel is allocating to that particular user, to the end user, that we will discuss in brief in today's session. So whenever user is calling to someone else, right? So whenever the user A is calling to user B, so the user A and B need to have a particular channel by which they can transfer that dedicated, or by the person A and the person B need a particular channel by which they can transfer their private data, right? So with the help of that particular and dedicated channel, the users can transfer their data, right? So how that channel is getting by that user and how that channel is allocating by the telecommunication company, that we will see in this today's session. So let's begin with the channel allocation. Where does it use and what is that, right? So channel allocation is used to allocate the available channel to the cells in the cellular system, right? When a user wants to make a call request, then by using the channel allocation strategies, their requests are fulfilled and the user is able to call the receptions, right? So that's how your call is dialed. There are mainly three kind of channel allocation strategies: fixed channel allocation, dynamic type, and the hybrid type, right? So what do you mean by the channel allocation, right? So channel allocation is the process in which a single channel is divided and allotted to the multiple users in order to carry the user specific task. It can be a simple call request, it can be a simple SMS request, and anything, right? It is carrying the user specific task. The channel allocation is the process in which single channel is divided. Whenever you are calling someone, so which kind of channel allocation is performing there, that will be discussed in today's session. So let's begin with channel allocation. So in today's session we will first of all discuss what is channel allocation, and after that its subtypes, right? So type of the channel allocation strategies we will discuss in brief. There are mainly three kind of channel allocation strategies: fixed channel allocation, dynamic type, and the hybrid type, right? We have a single channel, right? It is divided into the smaller amount of time, and that smaller amount of chunk is allocated to the multiple user to carry their specific information. There are users quantity may vary every time the process take place, right? It is not always possible that there is always an heavy traffic in the channel, or it is always a low traffic in the channel. It may vary by time to time, right? For an example, if there are n number of, it is not always possible that there is always an heavy traffic in the channel, or it is always a low traffic in the channel. It may vary by time to time, right? For an example, if there are n number of the user and the channel is divided into the n equal size sub channels, each user is assigned in one portion, right? So we have the n number of the user and we have divided our channel into the n equals size of the sub channel. So then after, each user can get n one portion of that channel, right? So but if the number of the users are small, the user and the channel is divided into the n equal size sub channels, each user is assigned in one portion, right? So we have the n number of the user and we have divided our channel into the n equals size of the sub channel. So then after, each user can get n one portion of that channel, right? So but if the number of the users are small, it is not always possible that there is always an heavy traffic in the channel, or it is always a low traffic in the channel. It may vary by time to time, right? For an example, if there are the n number of the user and the channel is divided into the n equal size sub channels, each user is assigned an one portion, right? So we have the n number of the user and we have divided our channel into the n equals size of the sub channel. So then after the each user can get n one portion of that channel, right? So but if the number of the users are small, we don't have to worry about that, right? So the number of the user are small and don't vary at the time, then the frequency division multiplexing can be used. We don't have to worry about that, right? So the number of the user are small and don't vary at the time, then the frequency division multiplexing can be used, right? So when the number of the users are small and they don't vary by the time to time, then we can use the frequency division multiplexing, right? So then we can use the frequency division multiplexing technique that can be used and as a simple and efficient channel bandwidth allocating technique, right? So when the number of the user are small and they are don't vary with time, right, they don't vary very frequently, then we can use the FDM, frequency division multiplexing, right? So let's begin with the fixed channel allocation. So what is that? It is a classical and a traditional approach of the allocating a single channel among a multiple competing user that uses the frequency division multiplexing, right? As we have discussed, if there are n users, the bandwidth is divided into the n equal size portion and each user being assigned an one portion, right? So since each user has the private frequency bandwidth, right? So there is no chances of the interface, right? So the collision cannot be occur then, because we are allocating an fixed portion of the size to the every user, right? That is not varying, so there is no chance of the collision. So if there are the n user and bandwidth is divided into the n equal size portion, then there is no chance of the collision, as the every user is having their own portion, right? So where does this fixed channel allocation technique is used, right? So it is a strategy in which the fixed number of the channel or voice channels are allocated to the cells. Once the channels are allocated to the specific cells, then they cannot change, right? For an example, in this cell A, you can observe that there are the 20 channels are allocated. If all the channels are occupied and user makes a call, then call is blocked, because all the channels are already occupied by some other user, so it is blocked at that time. So what is the solution about this problem? So we can borrow the channel handles in this type of the cell problem, right? So in this, the cell borrowing channel from the other cell that is nearby. You can borrow the channel from the B cell or from the C cell. There is in the B cell there are having the 5 channels and C is having the 10 channels. So you can borrow the channel handles from that cells also, right? So to overcome this problem, when all the channels are occupied and user makes a call, then to overcome that problem, they can borrow the channel from the nearby cells, right? So that's how the fixed channel allocation is working. So let's see some mathematical portion. So in that, the channel allocation is not efficient to divide into the fixed number of the channel. So what is the formula for that? The mean time delay is equal to 1 divided by u into c minus l, where t is the mean time delay, c is the capacity of the channel, l is the arrival rate of the frame, and 1 by u is the bit per frame, right? So you want to apply an FDM technique and want to calculate the time delay there. So T FDM is equal to n into T into divide by U into C divided by n minus L divided by n, right? So where n is the number of the sub channel, as you can find the mean time delay, you can simply multiply and divide the number of the sub channel. So that's how you can get the frequency division multiplexing time, TFDM, right? So that's how you can calculate the TFDM. After that, The another type is that is the dynamic channel allocation. So in the previous session, the fixed channel allocating, we are simply partitioning the single channel, and after that we are assigning that portion to the users or particular cells. But in this strategy, it is a strategy in which it is not permanently allocating the cells. So what is the thing that is performing in the dynamic channel allocation? So when a user makes a call request, then the call station send that request to the mobile station center for the allocation of the channels. This way the problem of the blocking calls is reduced. Right? We don't have to borrow the channels from the nearby cells. After that, there are some kind of possible assumptions include at the station model. In the station model, which kind of assumption we need to do? Assume that each of the n station are independently produce the frames. The probability of the producing a packet into the interval IDT, where I is the constant arrival rate of the new frame. Single channel assumptions. What is come under that? In this allocation, all the stations are equivalent and can send and receive on the channel. The collision assumption. So if the two frames are overlap in the time wise, then that's a collision. Any collision is an error. Collision assumption. If two frames are overlapped in time wise, then that is the collision. Any collision is an error, and both the frames must retransmitted. Right? If the two frames are overlapped in the time wise, that is the collision, and each of that frames must be retransmitted. Collision are only possible error. Right? The assumption about time. The time can be divided into the slotted or continuous manner. Station can sense the channel is busy before they try it. Right? So that's the assumption about the dynamic channel allocation. After that, the protocol assumption is the what kind of thing we need to assume about the protocol. There are the n independent station we need to assume. Any station is blocked until its generated frame is transmitted, right? While it is transmitting its frame, that station is blocked. Probability of the frame being generated in the period of length dt is IDT, where I is the interval rate of frame. Only a signal channel is available. The time can be either continuous or the slotted, as we have discussed. Carrier sense. A station can sense if the channel is already busy before the transmission, right? And the no carrier senses. The timeout is used to sense the loss of the data. That are the basic assumption about we need to concern about whenever you are using the dynamic channel allocation method. So that's all about the dynamic channel allocation. Let's move forward about the hybrid channel allocation. So this is, as its name suggests, the hybrid means the combination of that, right? So it is the combination of the fixed channel allocation and the dynamic channel allocation. The total number of the channels are divided into the fixed and the dynamic sets, right? So how it is used? It is having the fixed number of the chunks and the dynamic set. So how it is working? When a user makes a call, then the first, which kind of sets is used? The first, the fixed set of the channel are utilized, but all the sets are busy of that fixed sets. Then the dynamic sets are come into picture. After that, the dynamic sets are being used. The main purpose of the hybrid channel allocation is to work efficiently under the heavy traffic. It is giving the pros of the fixed length and the dynamic length, right? So it is giving the pros of the fixed channel allocation and dynamic channel allocation both, right? So under that, with the help of the hybrid channel allocation, we can work with the under the heavy traffic. So that's all about the channel allocation techniques, right? So that's how we have seen in brief that. So which kind of techniques we are using for the allocating the channel? There are mainly three types. fixed type, in which the channel is divided into the number of the chunks, and that chunks are allocating to the users, right, to the use. They are permanently given. After that, the dynamic channel allocation is coming to the picture. In that, the user need to request to the station, and after that the mobile station is granting the permission to use that chunk, right? And the hybrid chunk, in the hybrid channel allocation, which kind of techniques it is using? It is the collaboration of the fixed length, fixed channel allocation, and the dynamic channel allocation. With the help of the hybrid channel allocation techniques, we can work under the heavy traffic, right? So that's all about today's session. Thank you for the watching.